Hi students! Welcome to the fifth and last video in our series about Lewis structures. In this video, we're going to be talking to you about octet exceptions. So if you remember from our previous videos, we talked through this order of priority or importance between steric number, octet rule, and minimizing formal charge. So in this video, we're going to be talking about those atoms and molecules that don't necessarily have a full octet because they are in favor of fulfilling their steric number instead. So the first atom that we'd like to talk about is hydrogen. So hydrogen has only a 1s orbital, if you recall its location on the periodic table. As such, its steric number is confined to being 1. So it doesn't make double bonds. It will only ever be found in just a few forms, and in all of these forms, it will not have a full octet. So we can find hydrogen as hydrogen bonded to one atom, hydrogen with a plus charge, hydrogen with a negative charge, and hydrogen with just one atom, but that one's very rare. You'll not find that when it's associated with another atom or in a molecule. So the next atom that we'd like to talk about is fluorine. So fluorine in some ways is very similar to hydrogen. So even though it has more than just a 1s orbital, it has very high electronegativity. And so because of this high electronegativity, it wants all of the electrons for itself. And so it will only ever really be found in two forms when associated with another atom or in a molecule. So it'll have fluorine with a negative charge or fluorine bonded to one atom. So here you can see our two examples of fluorine. So note that there's one difference between fluorine and hydrogen, which we already kind of hinted at. So hydrogen will, as itself, as a peripheral atom, not have a full octet, even though it will limit the ability of a central atom that it's connected to form a full octet. However, fluorine is so electronegative that it can have a full octet for itself, even if, because it only forms single bonds, it can limit the ability of a central atom to have a full octet. Okay, so now let's talk about hydrogen and fluorine in some molecules. So the first one that we'd like to talk about is BH3. So this is in relation to boron. So quickly, we can just say and calculate that the steric number for BH3 is 3. If you're having trouble with this concept still, or if you'd like to know where the number 3 comes from, please revisit our previous videos. We talk extensively about the calculation of steric number. So let's think about this. So we already said and mentioned that hydrogen does not form double bonds. And so in this case, if we have a steric number 3, we have a trigonal planar formation. And so we would just connect boron with 3 hydrogens around it. And that's it. We can't do anything else because even if boron wanted to have a full octet, hydrogen cannot form double bonds. Additionally, because of its steric number, boron would not take on another electron pair because that would change its steric number. So both of our ways of adding electrons to the atom will not work. They're not able to add electrons in that manner. So now let's talk about BF3. So if you remember, we just talked about how fluorine also only forms single bonds. And so it's very similar. Once again, we have a steric number of 3, which means that we have a trigonal planar structure. And so we'll place boron in the center with 3 fluorines around it with 120 degrees each. And once again, that's all we can do here, because even though each fluorine will have a full octet and have all of its electrons added around it, it will only form a single bond with boron. And so boron will not be able to add another lone electron pair to itself either, because it's going to change the steric number. So next, we want to talk about two more examples, this time in relation to beryllium. So let's take a look at BEH2. So if we calculate the steric number for BEH2, we find that the steric number is 2, which corresponds with a linear molecular structure. So this time we'll put Be in the center with 2 H's to the left and right of it. And once again, we can only connect them with single bonds because hydrogen will only form single bonds. If any electrons are added to beryllium, we once again see that it would disobey the steric number and we would have a steric number that isn't 2. So now let's take a look at our final example, beryllium with 2 fluorines, so BeF2. So once again, we have a steric number of 2. You'll find that all of these trends are very similar. So this makes it linear, and so you'll have Be with 2 fluorines to the left and right of it. So once again, fluorine will be able to fulfill its octet, but beryllium will not, because beryllium has a steric number of 2, and adding any electrons to that would change the steric number.